Hello, I'm Chris Jones. I'm Ecosystem Director for Integrated Infrastructure Connected Places Catapult, and I want to talk to you today about our work in using digital twins to improve infrastructure resilience to climate change. So extreme weather events, including storms, floods, extreme heat and drought, are on the rise due to the impact of climate change. And in the face of this, our infrastructure must remain in operation and respond to the changing demands on their networks. So it's therefore essential that infrastructure owners and operators keep their strategies for asset resilience under review and maintain an accurate picture of the vulnerability of their networks at all times. Our role at Connected Places Catapult is as an accelerator. So we're interested in business growth and stimulating markets. And we were established by the UK government as a long-term investment to grow the UK economy. We bring together cutting-edge research and development infrastructure, ability to build partnerships, and specialist knowledge to accelerate the development, deployment, and adoption of new technologies. Catapults make today's industry more productive and create the markets of tomorrow. At Connected Places Catapult, we do this focusing on cities and transport and place leadership. And we're driven by what we describe as our innovation imperatives: connected intelligence, climate action, and people's experience. As I said, extreme weather events, including storms, floods, prolonged heat and drought, are on the rise due to the impact of climate change. And it's very difficult to accurately forecast the impact of climate change on infrastructure networks or their customers. There's an increase in recognition across the UK government that we are poorly prepared for such events in the future. The UK's Climate Change Committee has been saying that we have a poor understanding of the interdependencies across infrastructure networks, that it's not well understood how a failure in one network, such as power, might cascade and impact communications, transport, or water, and what the overall impact is. Infrastructure needs to remain in operation at all times, as I said in my introduction, and it's therefore essential that we focus on resilience. In response to this challenge, we've developed a project called CReDo, the Climate Resilience Decision Optimizer, to help asset owners become better prepared in the face of extreme weather events, which we know are only going to get worse. So CReDo, as we call it, is a climate change adaptation digital twin that connects across organizations and sectors. By breaking down data sharing and sector silos, we can collectively understand cascading risks and understand how to improve overall system resilience and robustness so that we can make better coordinated decisions at the lowest cost. So for the past few years, Connected Places Catapult have been developing a demonstrator project involving some large infrastructure owners in the UK, UK Power Networks from the power sector, Anglian Water from the water sector, and British Telecom from the telecom sector. And we've modeled their combined electricity, water, and telecoms networks. We originally looked at the use case of flooding. We used system-wide impact modeling to see, for example, how a localized flood could shut down a primary substation and how this might impact the loss of power on a secondary substation. But of course, when the power goes down, that impact can cascade across sectors, and we can lose power to telephone exchanges or mobile phone masts or water boosters. And it potentially means a loss of electricity, water, telecoms to customers and businesses, as well as a knock-on impact back on the energy system. So the development of CReDo has been an ambitious innovation project. It's involved multiple partners across research and industry, and we've been tackling both societal and technological challenges, including digital twinning, data sharing, modeling, and we've been receiving from the digital twin actionable insights for decision makers that are leading to improvements in how network operators think about resilience of their system. Overall, our goal is to scale CReDo up, so not just to look at power, water, and telecoms, but to include other networks, such as transport or the healthcare sector. So we've developed a data architecture at the heart of CReDo that's extensible and uses knowledge graph technology. And in the future, we'll be using these to scale to include more networks, their different assets across different geographies, not just in the UK, but hopefully overseas, and thinking about different use cases and climate events. And these designs will be intended to make our system interoperable with other technologies that are being developed across the world. As well as flooding, we've already started to think about the impact of extreme heat on infrastructure assets. And that's really timely, given that 2023 was the hottest year on record across the globe. I've got a bit of a cartoon here now, so a visual description, which I'm going to talk you through to help you understand really what we're doing when we talk about connected assets and systems. So let me talk you through this. We start with a network of assets. So you can see the electricity assets in yellow, the telecoms assets in purple, and the water assets in blue. And in the middle of the screen, just above the river, which is the blue line, you'll see what I describe as an upstream power asset. When this asset fails, it's hard to predict how other assets downstream of it might be impacted. There we go. So now you can see that a flooding event has occurred and that electricity asset has now failed. It's got a red ring around it. If we were using the CReDo architecture, we would understand the interdependencies across this asset network. So the green arrows demonstrate those interdependencies. That primary substation feeds a secondary substation that goes on to power telecoms and water networks. And when the arrows are green, it's all working brilliantly. But if the flooding were to become more severe, and if the mitigations around that power substation or its flood defenses are not adequate, you can see that a failure of that power substation cause cascading impacts throughout that connected network. And the red arrows indicate that all connected assets have now failed. We can understand these interdependencies because of the approach we've taken with CReDo. Now, of course, each of the asset owners, the electricity, the water, and the telecoms asset owners can decide to make individual mitigations around their assets to future-proof them, I guess, towards a 1 in 100 flooding event, but in a siloed way. And of course, that can work for some time, but what were to happen if, for instance, a 1 in a 200-year flooding event were to occur? Their individual mitigations would be insufficient, and actually their assets would still be flooded and go offline. What CReDo can do is really identify the critical assets in networks, and asset owners can think about getting together and instead of individually invested in the resilience of their own sector assets, we can see through the CReDo representation that the critical asset in this network is that primary substation. And what we're able to do is to provide insights to the water and telecom sectors that actually they need to be invested in power resilience rather than resilience around their own assets. So what we're doing is encouraging those who are involved in resilience investment planning across infrastructure sectors is to think about really where the mitigation needs to take place to lead to the highest impact at the lowest cost. So I hope that was a helpful cartoon. So within CReDo, we not only map the interdependencies across assets, but we model data that showcase the critical assets within failure models. And we can look at how much money it might cost an asset owner be that in fines for a service downtime, or in repairs, or in lost custom. And this allows asset owners to make better decisions over where to put their investments. And as I said earlier, that might be within their own asset sectors or potentially in other asset sectors such as power. So in the example that I gave, if you're the telecoms or water company with assets downstream from that primary substation, you're better off investing in power sector resilience than in your own assets. To give you a flavour as to how CReDo works, it all starts with data from different assets being combined within the CReDo knowledge graph, which you should think about as a connected database. And from here, we feed in geographical weather data, like the height of a flood, to understand how each asset in the network is locally impacted with our asset impact models. And then we run our system-wide models that look at cascading failures or impacts throughout the rest of the connected network. We then apply economic modeling to determine the costs of a specific event happening and what the impact of that would be on a specific operator and on wider society. And then we use artificial intelligence or decision intelligence to identify the best coordinated mitigation strategy to build stronger flood defenses at critical sites, or in the case of extreme heat, how to mitigate against extreme heat impacts at critical sites. So the data and the insights are then fed back to the users, the asset owners. They can visualize them in a map and a dashboard, and they can make decisions around building climate resilience across their network based upon that feedback. So the expected benefits of CReDo are broad. It's expected to bring benefits to network operators, their customers, and to wider society. Previously, we've done some economic modeling on the benefits of having an improved understanding of infrastructure interdependencies and how that might impact the strategic planning for resilience and robustness. And overall, we see that the CReDo's decision intelligence approach delivers a significant benefit cost ratio around flood resilience. We also found that CReDo would deliver a higher level of resilience across the system at a lower cost relative to the counterfactual situation of only investing in siloed resilience planning. And our future work is going to quantify the benefits of not the flooding climate case, but the extreme heat use case, as well as looking at some of the benefits of improved adaptation reporting or contributing to business planning and price reviews in the UK. So it's worth, as we come towards the end of the talk, just to think about the mission and purpose and objectives of CReDo as a whole. And hopefully I've given you an idea of the types of challenges that CReDo is trying to solve. I'll talk about its journey in a moment as it's gone from demonstrator to decision optimizer. So really in its demonstrator phase, we're trying to prove the concept that we could bring together infrastructure sectors to share data, that we could deliver intelligence through digital twin technologies. And now we're moving into a scaling phase where really what we're doing is using the technology to optimize the decisions made about critical national infrastructure. Thinking about the core objectives of CReDo, the first is around showcasing the power of bringing together siloed data. So this adds transparency across sectors. It showcases the interdependencies across sectors. It allows siloed data to be brought together that enables us to think of a whole infrastructure system. And this mitigates risk and allows infrastructure owners to save money in the process. Secondly, enabling and improving strategic resilience planning. So this takes into account everything I've just explained, including how we best utilize investment to better prepare for future extreme weather scenarios. And then thirdly, of course, arguably the most important point is benefiting society people and businesses that rely on our infrastructure being resilient and robust every day. We need to make sure that everyone has access to power to heat their homes in winter, that they have access to clean drinking water, that sanitation works appropriately, and that you're able to pick up the phone to call the emergency services when you need to. I've talked a little bit about where we are with CReDo now, and of course there's huge potential for expansions to the model. We've developed it with a highly extensible architecture, and we're looking into a number of very interesting additional capabilities. And these tend to sit across a number of categories that include data sharing and the core technology, developing better asset models, developing better cascade models, and then other ways to scale and retrieve data and replay insights back to asset owners. We're very keen to expand geographically. We have plans throughout 2024 and 2025 to develop UK-wide models. At the moment, we're modeling different regions of the UK. We'd like to consider applications of CReDo in specific cities, both in the UK and overseas. We hope to expand our sector representation beyond energy, water, and telecoms. And the transport sector seems to be an obvious place to go next. And I talked about expanding in climate against different climate resilience scenarios. So we've looked at flooding extensively. For the last year, we've been looking at extreme heat, but we may go on to look at other extreme weather types, including extreme wind, and we'll take soundings from the industry as to what else they're concerned about in terms of climate change impacts on their infrastructure. This slide here just really shows the journey that we've been on with the CReDo project. And it's the journey from idea to demonstrator to scale up and eventually to product, which we hope we'll reach by 2025. So our inspiration for CReDo on the left-hand side of this slide came in 2017, and there was a report from the UK's National Infrastructure Commission, Data for the Public Good. And it talked about the need for cross-sector data sharing, and that really gave us the seed for the idea. And then in March 2021, CReDo began at the Centre for Digital Built Britain at the University of Cambridge, also including the Digital Twin Hub. And then it led to the involvement of Connected Places Catapult for the first time, working as part of the team to create that centralized architecture, looking at flooding climate scenarios. In March 2022, Connected Places Catapult took on the CReDo project as the lead organization. We started to move the data architecture from centralized to distributed so that the data stays with the data owner. And we worked extensively with the water, power, and telecoms asset owners to trial the platform. And we're together now moving it towards that minimum viable product. For March 2023, we've also been working extensively with the regulators of the water and power sectors in the UK who are really interested in climate resilience. Those organisations are named Ofgem and Ofwat. And in the coming year, we'll be completing some further work to look at the scalability of our data sharing license and architecture that allows other asset owners from the water, power and telecom sector to join the project so that actually our system representation grows, but also includes or allows for other sectors such as transport to plug in. So it's an exciting time, and we're really in a scale-up phase as we're moving towards the launch of the CReDo product. So finally, none of this would be possible without extensive collaboration. This is not something we've done alone at Connected Places Catapult. What we've done is convene the right innovators and partners to make this program work. And I'd just like to acknowledge those organizations whose logos are represented on the screen today. And of course, if you would like any further information about CReDo, then do feel free to contact myself, Chris, or Dr. Elliot Christou, who's our technical lead for CReDo and has helped extensively over the last few years with delivering the successful project. Thank you.